This is an RNZ podcast.
Kia ora, haere mai, and a very big warm welcome to Elemental from RNZ. I'm Alison Balance, and in this alphabetical ramble around the periodic table, I'm excited. We are finally at the end of the elements whose names start with the letter A.
And I'm Allan Blackman. I'm a chemistry professor at Auckland University of Technology. And speaking of letters on the periodic table, we were discussing in an earlier episode the fact that there was apparently one letter that doesn't appear on the periodic table.
And you wouldn't tell me what it was?
And I wouldn't tell you what it was because actually I got that wrong. There are two letters that don't appear on the periodic table. So, any guesses, Alison?
My first go-to guess might be Q.
Yes, indeed. Q is one of
Hurrah!
them. And the other?
Well, I know there's Zs. I know it goes to zirconium.
Yes, it does.
I'm going to say J.
Oh, very good. Well done.
Oh, you mean
Goodness
I got
me.
it right?
You did.
That was a very lucky guess.
And that wasn't pre-done, folks. That was totally off the cuff.
Excellent. So today's element, though, is still with the A's, is another enigmatic one that chemistry ignoramus that I self-confessedly am. I've never heard of. What is it?
Well, this is astatine, and it has got the chemical symbol AT.
Shouldn't it be AS?
Yeah, AS would have made sense, but arsenic got that first.
Oh, of course. It's just who gets in first, eh?
Indeed it is.
So this one's AT.
This is AT, and it's element 85 on the periodic table, which puts it right down the bottom right-hand side of the periodic table. And it sits in a group of elements which are collectively known as the halogens.
Now, I need to get you to explain groups to me, please. And I'm thinking that if you think about the whole periodic table, say as a village, then are the groups a bit like extended families that are related even though they all might be quite different? Does that work at all as an analogy?
Yeah, it sort of does. Maybe better to think of it in terms of, for example, groups of people who are sort of linked by a common profession or something like that. So let's say food. So people could be bakers, they could be chefs, they could be butchers, but they've all got that one thing in common, that they all sort of have food-related professions.
Can I actually see a group on the periodic table? Do they physically sit next to each other?
No, not so much next to each other as on top of and below each other. So groups on the periodic table are columns, and so they go from top to bottom. And on the periodic table there are 18 groups of elements. And the whole thing about a group of elements is that chemically they do behave quite similarly. And that's why Mendeleev put them into those groups in the first instance.
So you said astatine's a halogen. So what's it sitting with?
So that sits in group 17 with the other halogens, and the other halogens are probably elements that you're fairly familiar with, I would imagine. So fluorine, chlorine, bromine and iodine, and they're all above astatine, and then below astatine is a very, very recent element called tennessine, which we will talk about at a later date. And I say that they are all sort of very chemically similar. Physically, they're actually not quite so similar. And group 17 is a very unusual group of elements because at the top of it, we've got two gases. We've got fluorine and chlorine, which exist as gases at room temperature and pressure. And then we come to bromine, which is one of the only two elements that are liquid at room temperature and pressure. And then we go to iodine, which is a solid. And as we're going to see, we don't know what astatine is, but our best guess is that it's going to be a solid.
That's really curious that this one group can have gas, liquid and solid. Is that common?
No, it's certainly not common at all. You generally find that most of the members of a group are either sort of solid, liquid or gas.
So we've got lots of different states in that group. What do they actually have in common? What defines them as a halogen then?
Well, the word halogen comes from salt producing, and in chemical terms, it means that they would really like to grab one more electron and have a negative charge, a single negative charge, and that's what all of them do. So you've heard of chloride, for example, in sodium chloride. How does that differ from chlorine? It's a chlorine atom to which one more electron has been added to make a chloride ion. And all of the group 17 elements do this. They all form a one negative charged ion. Fluoride, chloride, bromide, iodide.
Well, all of those things, you're right, they are things that I come across regularly. I mean,
Yep.
the first thing that comes to mind, I'm thinking of chlorine in swimming pools, for instance.
Indeed.
So why don't I know about our element of today, astatine?
That's because it's very, very rare. And some people do say that it is, in fact, the rarest naturally occurring element on the planet. And that's where it actually got its name from. So the Greek astatos, meaning unstable. So depending on what books you read, you'll find astatine given as the rarest naturally occurring element. In other books, you'll find francium being given as the rarest naturally occurring element.
Who's right?
Well, that's a very, very good question. Often they say there's around about 25 grams or 30 grams or so of francium or astatine on the Earth at any given time. The thing is, nobody's ever seen these particular elements. They're only formed in such tiny, tiny amounts that nobody has yet made a sort of a macroscopic sample of astatine. The reason being that astatine is radioactive. And so as soon as you form it, it's got a very, very short half-life, only around about 8 hours or so, that it just decays away into another element. And it's also been surmised anyway that if you could make a sample of astatine that was big enough to actually see, then it would vaporize instantly because the heat given out as a result of the radioactivity would cause it to just disappear. So it's quite remarkable stuff.
So there's barely any of it. We've never seen it. I take it we don't know very much about it then?
Yeah, we don't know a heck of a lot about it. We do know something about it because of the fact that it's radioactive, and so therefore that gives you a very nice handle by which to measure its reactivity. And things like melting points, boiling points, colour, etc., those sorts of things, we can infer those properties from its place on the periodic table, which is one of the great strengths of the periodic table.
So when did we even discover astatine?
In the sort of late 1930s, early 1940s, there was an obvious gap again in the periodic table at number 85, and so scientists or chemists around the world were busy trying to make this new element. And they finally succeeded in 1940, where they first made it in the laboratory, which might seem a bit strange for an element that's naturally occurring, but it was found to be naturally occurring sort of slightly after that, around about 1943. So in the war years, and again, you've got scientists on, sort of both sides of the globe and both sides of the war, I guess, busy working really in isolation and, one not knowing what the other's doing.
I take it that because it's so rare, there's no practical uses for it?
Yeah, you're pretty right. There are potential uses for it in medicine, maybe in cancer treatment, but that still is probably a long way off. Very, very difficult to do. And, just the fact that there's so little of it does make it tough.
Yeah, I think it's pretty tricky to treat somebody with it as a medicine when you haven't even seen the damn thing. Anyway, next time on Elemental, we'll have a little bit more to say about the element barium.
Until then, I'm Professor Allan Blackman from Auckland University of Technology.
And I'm Alison Balance. You've been listening to Elemental, a podcast from RNZ. Find us online at rnz.co.nz/chemistry or subscribe to us as a podcast. You'll find it in all the usual places. I have a favour to ask. If you're enjoying Elemental, please share it around, tell your friends and family about it, and even rate and review us if you can. Thanks heaps. We'll be back soon, but for now it's cheerio from us. See ya.
See ya.